Charge tape revisited. In this experiment, the analysis of 2 pieces of charge tape from lab 1 is redone to consider the charge of the tape as being uniformly distributed over the tape plane. The charge of the tapes can be determined using VPython to model the interactions of 2 charge tapes with uniform charge distribution. A summary of the result from this experiment is shown with the charge of the tape is positive and equaling 2.39 times 10 to the negative 8 coulomb. The first 2 key concepts are Newton's second law and the gravitational force near the Earth's surface. Newton's second law states that the net force on an object equal to the change in momentum of the object over time. The gravitational force near its surface is equal to the mass of the object multiplied by the gravitational constant and is pointing at the negative y direction because the tape has a uniformly distributed charge over its length. Can be described as a uniformly charged rod. The electric field of a uniformly charged rod at an observation point perpendicular to the rod at the midline of the rod is similar to the electric field of a point charge, except that the length of the rod must be considered in this lab. This equation is used as a preliminary estimator for the electric field of the tape. The electric force, also important concept for this non-contact force, states that the force that is a charged object exerts on another charged object is equal to the 2 equations shown. Importantly for this lab, the electric force is equal to the product of the charge and the external electric field that acts. There are 3 key assumptions. First, the most important one, we assume that the charge of the tape on the charge on the tape is uniformly distributed over the length of the tape. Second, air resistance is ignored. Third, both tapes have the same amount of charge. Here's the procedure for creating the 2 charge U tapes for lab 1. Here are the main observations for the U tape interactions. Importantly, the charge of the U tape was determined to be positive because it was attracted to a negatively charged plastic object. Here's a free body diagram of the interaction between the held U tape and the suspended U tape, where the suspended tape to a flow. It must be in equilibrium. This means that the net force of the tape is 0. The system is the suspended U tape and the surroundings included the held U tape and the earth, which exerts forces on the system. Here are the experimental data and some calculations based on the experimental data. Important values include the mass of the tape, the separation distance. As stated later, the uniformly distributed charge of one tape can be estimated by using the electric field of the uniformly distributed tape equation. The bottom tape, which produces an electric field that influences the force on the tape. The top tape is the rod. The top tape is the observation point, which is shown as a point charge. For the calculation, while this method is not accurate estimator of the true charge, the result is a good ballpark estimate. Here are the constants and experimental values for the computational model, which is done using Python. Note that the UFAS and the Coulomb constant is also, note that the true charge of the tape is 2.39 times 10 to the negative 8 coulombs. Here's the electric field function of the code used to compute the electric field of a point charge in this lab. The tapes are separated into 30 point charges, which approximates the interval method used to calculate the electric field of the uniformly distributed charge. Here, the code shows the calculations done to find the electric force from each point charge, as well as the calculation of the total electric force on the top tape by the bottom tape. The electric field at the top tape due to the bottom tape is also calculated. Here are the code for the errors representing the electric force and the force due to gravity on the top tape are shown. Here are the results of the Python code. The charge of the tape, according to the code, is through a guess and check method, is 2.39148 times 10 to the negative 8 coulombs. The number of